We are going to have a bit of a discussion about how we can multiply terms together in algebra. Now remember, terms were just pieces that make up our algebraic expressions. We'll look at some examples, but first I have to talk about some really important information when it comes to multiplying. In algebra, you need to remember that if you see something like 3x, it means 3 times x. There is this invisible multiplication sign. So between a number and a letter, okay, there's a multiplication sign. You can't see it, it means 3 times x. So in this case, minus 4mn would mean minus 4 times m times n. We just leave out these multiplication signs, okay? So that's important. The other important thing is that we can multiply in any order. So by that, if I took the numbers 1 times 2 times 3, I'd get the same answer if I did 3 times 2 times 1 or 1 times 3 times 2. It doesn't matter what order we multiply things in. So both of those things are going to be handy and important when we start to talk about how we do multiplication with algebra. Here is an example. 3x times 2. Now looking at my little notes that we just discussed, I know that 3x means 3 times x. So when I multiply these two pieces together, what do I get? Okay, here are the steps. First of all, expand by just putting the multiplication signs back in. So there's one missing from here. Let's just put it in. So now I know that I'm doing 3 times x times 2. Remember, we can multiply in any order, so I'm always going to try and do the numbers first. So 3 times 2 gives me 6. Now I haven't touched the times x bit, so I've just dealt with the numbers. And then what you would do then normally in any question, now you would put the letters in alphabetical order. Now there's only one, so it doesn't matter, but we'll look at an example in a moment where it does matter. And then the last step finally is I take the times sign back out. Okay, so my 6 times x, I write it as 6x. That's my answer. 3x times 2 was 6x. So those steps again, I put the times signs back in, multiplied the numbers together, put the letters in alphabetical order, and then took the times sign back out. So we're going to follow the exact same process, step by step, to do this one. 5y times 8x. Right? Now you'll see these are not like terms, 5y and 8x, from a previous video. Remember, we can only add and subtract like terms, but when we're multiplying, they don't have to be like terms. We can actually multiply them together. So let's see how. First step, put the multiplication signs back in, which is what we've done here. Do the numbers first. 5 times 8 gives me 40. And the rest I just leave as it is. Okay, the times y and the times x. The next step, just put the letters in alphabetical order. So I'm going to swap these two. And then take out the times signs. And I'm left with 40xy. Awesome. We've done it. We've multiplied together 5y and 8x. Okay. We've multiplied the numbers together to get 40 and y times x, but we've written it the other way around, x times y, because we can do it in any order. Lastly, here's a bit of a fancy one, 9ab in brackets times minus 5a in brackets. Hey, the process is just the same. We can remove the brackets, put in all the multiplication signs, so in there and there, and one in there. Do the numbers first. Now be careful when you're multiplying a positive number by a negative number, your answer will be negative. So 5 9s are 45, but because I've got a positive and a negative, my number becomes negative 45. Put the letters in alphabetical order. Now I've got A, B, A, so I'm going to change that to A, A, B. Now the only little twist here is that when I've got something multiplied by itself, in this case A times A, I can write that as A squared. Okay, because 3 times 3 is 3 squared. 4 times 4 is 4 squared. So A times A is A squared. Now I can take out the times signs and I've got everything done. Right? I've got 9ab times negative 5a gives me an answer of negative 45a squared b. That is how we multiply terms together in algebra. And if you just follow those steps, you can't go wrong no matter how tough the question looks. Well done.